All right, your training circular 9237, operator circular welding theory and application, report of errors and recommendation improvements, May 1993, approved for public release unlimited. And then we're going to start at 710. We'll try to finish chapter 710. Or it's chapter 7. Uh, it's still. Alright, it's 710. General descriptions. General description: weldability of ferrous metals, low carbon steel, general low carbon mild steel, include with the carbon content up to 0.3.0%. And most low carbon steels, carbon ranges from 10 to 25%, 25%, 10 to 2,500% of to 0.05% maximum. Steels in the range are widely used with industrial fabrication construction. These low carbon steels do not harden applicable to welded, therefore do not require preheating or post heating except in special cases such as when the heavy sections are to be welded. In general, no difficulties are encountered when welding low carbon steels. Properly made low carbon steel welds will equally exceed the base metal in the strength. Low carbon steels are soft, ductile, and can be rolled and punched and sheared and worked with, and has a rough, dark gray surface except as when where machined. Rolled steel has a fine surface shape, hammer marks and fins. Fracture color is usually recognizable, but is shape and hammer marks and fins. Fracture color is bright crystalline gray, and the spark test yields sparks with long yellow-orange breaks will have tendency to burst. White fork sparklers. Steel gives off sparks when melted. Solidifies almost instantly. Low carbon steels can easily be welded with any of the arc gas, or resistant welding processes. All right, low carbon steels. Carbon coated low carbon rods should be used with low carbon steel with low. The rod size of various plate thickness as follows: 1/16 to 1/8 of an inch for rod diameter 1/16 of an inch. One plate thickness 1/8 of 3/8. Rod diameter 1/8 of an inch. Plate with thickness of 3/8 to 1/2 inch. 3/16 of an inch diameter rod. 1/2 inch plate thickness. 1/4 inch rod diameter. No, rods 5/16 of an inch through 3/8 of an inch are made available with heavy welding. However, the heavy welds can be made with a 3/16 quarter of an inch rods, properly controlling the puddle and melting the rate of the rod. The joints may be prepared by the flame cutting or machining. Type of the preparation is determined by plate thickness of the welding position. And then it shows you a single V groove, a double V groove, a single U groove, and a double U groove. Welding penetration. The flame should be adjusted with neutral, either forehand or backhand. Welded method may be used depending on the thickness of the plate being welded. Molten metal shall not be overheated because it will cause the metal to boil the spark excessively. With the resultant grain structure for the welded metal will be large and strong enough. Strength lowered and weld badly scared. Low carbon steels do not harden in the fusion zone as a result of the welding. Metal arc welding. When metal arc welding, low carbon steel for the bare, thin, and coated, heavy coated shielded arc type electrodes may be used. Electrodes are low carbon content of a tenth to 14th of 100%. Low carbon sheet plate materials have been exposed at low temperature shall be preheated slightly to the room temperature before welding. Welding sheet metal up to 1/8 of an inch thickness is plain square butt joint with the edge of the preparation be used. The long seams are to be welded with these material. The edges should be placed. Allow shrinkage because of the deposited metal tends to pull the plates together. The shrinkage is less severe in arc welding than in gas welding. Spacing is approximately 1/8 of an inch will be sufficient. The backstep welding technique should be used with the short seams and used in fixed in places will prevent warpage and distortion and will minimize residual stress. Every plate shall be beveled to provide and include up to an angle of 60 degrees, depending on the thickness of the part, shall be tacked welded into place in short intervals along the seam of the first end. The root bead shall be made within an electrode small enough in diameter to obtain good penetration fused at the base of the joint. 1/8 of an inch, 5/32 of an inch electrode is suitable for this purpose. The first bead should be thoroughly cleaned and chipping and wire brushing before adding layers of welded metal to the deposit. Additional passes of the filler metal shall be made with the 5/32 of 3/16 of an inch electrode. The passes should be made with a weave motion of flat, horizontal, or vertical positions. Overhead position, the best result is obtained using stringer beads throughout the weld. When welding heavy sections having bevels of both sides of the weave belts beads should be deposited alternately on one side and the other. This reduces the amount of distortion while the structure each bead should be cleaned thoroughly with the remove all scale and oxide slag before additional metal is deposited. The motion of the electrode should be controlled as to make as the bead uniform thicknesses and to prevent undercutting overlapping edges of the weld. All slag and oxides must be removed by the surface of the complete weld to prevent rusting. Carbon arc welding. Low carbon sheet with a play of 3/4 of an inch in thickness of the weld with carbon arc welding process. The arc is struck against the plate edge of the prepared manner similar to the required with the metal arc welding. Flux should be used with the joint and filler metal shoes should be added with the oxyacetylene welding. Gas shield should be provided around the molten base filler metal by means of flux-coated welded rod should also be provided. Welding must be done by overheating the molten metal with the failure to observe the precautions can cause the welded metal to absorb an excessive amount of carbon electrode, oxygen, nitrogen from the air with the brittleness of the welded joint. Medium carbon steels. General. Medium carbon steels are non-alloy steels which contain up to 3 hundredths to 55 hundredths of a percent. These carbons shall be treated with the fabrication of the general machining forging, which requires surface hardness and strength of the manufactured in the bar form in the cold, rolled, normalized, and annealed condition. The heat-treated steels are welded and should be preheated at 300 to 500 degrees, depending on the carbon content. The thickness of the steel and the preheating temperature may be checked applying a stick to 50-50 solder melting point of 450 degrees to the plate at the joint, noting that the solder begins to melt during the weld. The welding zone will become hardened and cool rapidly. Must be stress relieved after the weld. Medium carbon steels may be welded with any arc gas resistant welding process. With higher carbon magnesium content, low hydrogen type of electrodes should be used with a particular thicker sections. Electrodes low carbon, heavy coated straight reverse polarity type, similar to those of the use of low metal arc welding, low carbon steel, satisfactory welding, medium carbon steels. Small parts should be needled and induced softness before welding. These parts should be preheated with the joint with welded with a filler rod to produce heat treatable welds. After welding, an entire piece should be treated to restore original properties. Either low carbon high strength rod can be used for welding. Medium carbon steels welding flames should be adjusted with a slightly carburizing puddle of metal kept with the smallest possible sound of the joint. Welding with a carbonized flame causing metal to heat with quickly because of the heavy giving off the steel absorbed with the carbon. The permanent welding at higher speeds. Care should be taken to even slowly cool the parts after welding, prevent cracking of the welding. An entire weld part must be stress relieved by heating between 1100 and 1250 degrees for 1 hour per inch of thickness of then slowly cooling, and cooling can be accomplished covering the parts with a fire-resistant material or sand. Medium carbon steels can be brazed and preheat 200 to 400 degrees and are good bronze rod and a brazing flux. However, these steels are better welded with the metal arc welding process. Metal shields arc electrodes. When welding metal mild steels, keep the following general techniques in mind. The plate shall be prepared with a welding manner similar to that used with the low carbon steel. For the welding low carbon steel electrodes, the weld heat should be controlled to avoid overheating of the welded metal. Excessive penetration into the sidewalls of the joint control accomplished with the directing electrode making toward previously deposited filler metal adjacent with the sidewall stored with the sidewall directly. By using the procedure, the welding is caused to wash up against the side of the joint and fuse it without deep excessive penetration. Alright, high welding heats will cause large and base metal with the fusion with adjacent weld to become hard and brittle with the air of the hard zones with the base of the keep that can be kept at the minimum, making the weld series of small string and weave beads which will limit the heat input. Each weave layer of the weld metal will refine the grain in the weld immediately beneath it and will anneal lessen the hardness produce the base metal and previous bead. When possible, finished joints should be treated with the after welding, stress relieving. The normally we use joining mild steel and high carbon alloys should be annealed. In welding, carbon steel with a stainless steel electrode, the metal should be deposited with a stringer bead with the overhead to prevent cracking with the welded metal in the fusion zone. Depositing welded metal upper layer welds made of heavier section weaving motion electrodes should not be used. Not exceed 3 electrode diameters. Each successive bead shall be chipped, brushed, and cleaned prior to laying in another bead. Are your high carbon steels. General high carbon steels include those with the carbon content exceed the 55 hundredths of a percent of the unfurnished surface. High carbon steel with a dark and gray, similar to other steels. High carbon steels usually provide with a very fine grain fracture, whiter than low carbon steel. Tool steel is harder and more brittle with a plate of steel with other than low carbon steels. High carbon steels can be hardened and heated with a good red quenching in water. Low carbon steels with raw iron and steel castings cannot be hardened. Molten high carbon steels is brighter than the low carbon steel with a melting surface of cellular appearance. All right. Low carbon steels and cellular appearance. It sparks more used to manufacture tools which are heated treated with the application develop the hard structure necessary withstand high stress and wear, and manufactured with a bar sheet with the wire forms and yield normalized and yield with the condition in order to be suitable for the machining. Before heat treatment, the high carbon steels are difficult to weld because of the hardening effect of the heat with the welded joint when it becomes high carbon content. Heat treatment usually given to these steels are the basic properties impaired by arc welding. Welding heat changes the properties of the high carbon steel with the vicinity of the weld with the restore original properties. High treatment is necessary. High carbon steels are preheated between 500 and 800 degrees Fahrenheit before welding. Preheating temperature can be checked by pine stick, which will char at these temperatures. Since high carbon steels are melt at a low temperature, local medium carbon steels cars should be not overheat the weld base or weld or base metal. Overheating is indicated by excessive sparking, and molten metal welding should be completed as soon as possible. Amount of sparking should be used as the check of welding heat. The flame should adjust to carbonizing type of the flame to produce sound welds. Alright, either a medium with a high carbon rod should be used to make the weld after the welding in the entire piece. There should be stress relief with the heating between 1200 and 1450 degrees Fahrenheit for 1 hour per inch of thickness, then slowly cooling. This part should be softened before welding. High carbon welding rods should be used to make the joint. The entire piece should then be heat treated to restore original properties of base metal. In some cases, the minor repairs of these steels can be made by the brazing, but the process does not require the temperature for the high with the used welding, so that the properties of the base metal are not seriously affected. The brazing should only be used in a special case because the strength of the joint is not as high as of the original base. Either mild steel or steel electrode can be used with the high carbon steels. Metal arc welding in high carbon steels requires critical control of the welded heat. The following techniques should be kept in mind. The welding heat should be adjusted to provide with good fusion inside walls root when of the joint without excessive penetration. Control of the welding heat can be accomplished depositing of the welded metal with small stringer beads. Excessive puddling and heating puddling of the metal should be avoided because of this can cause carbon to be picked up from the base metal with the turning, make it in the weld metal harder and brittle. Fusion between the filler metal and side walls shall be confined to a narrow zone using surface fusion provided procedure prescribed medium carbon steels. Are the same procedure for the edge pressure preparation, cleaning with the weld, the sequence of the welding beads method, prescribed low medium carbon steel and applies to the high carbon steels. Small high carbon steels sometimes repair, build up, worn surface of the dome of the place and yield with the softened heating of the red heat and cooling slowly. The piece should be then built up with a medium carbon high strength electrodes, heat treated after welding after restoring the original properties. Alright, tool steel. Just checking to see if we're recording. Alright, tool steel. General steel used for the making tools, punches, knives are perhaps the hardest and strongest stuff to steel within the industry. General tool steels are medium to high carbon steel with the special elements include a different amount that provide specific characteristics. A spark test should show moderate large volume with the white sparks having many fine repeating bursts. Carbon is provided with the tool steel to help harden the steel, cutting, wearing resistant. Other elements are provided with greater toughness and strength. In some cases, elements are added with the retained size and shape of the tool during the hardening operation to make the hardening operation safer and provide red hardness too, so that the tool remains in hardness. Hard strength. When it becomes extremely hot, the iron is a predominantly element with the composition of the tool steels. Other elements include with the chromium, cobalt, magnesium, bendium, nickel, tungsten, vanadium, and the tool die steel are designed as special purpose dependent upon composition. Certain tool steels should be produced with the die blocks are made with the producing molds other than high-speed applications. Another way to classify tool steels is according with the type of the quench. If it required with the hardened the steel with the more severe the quench after heating in the water quench water hardening steels. Less severe quench the oil quench obtained by cooling and tool and oil baths, oil hardened steels. At least drastically quenching is quick cooling in the air hardening steels. Our tool steel dies also can also be classified according to the work as to whether to be done by the tool or based on the class numbers. Class 1 steels are used to make tools that work with the shearing and the cutting of the application cut-off die, with the shear of the die, with the blank of the die, and then trimming the dies. Class 2 steels are used to make and produce the desired shape of the part, with causing the material worked in either hot or cold to flow under the tension, and include the drawing dies, forming dies, reducing dies, forging dies, plastic molds, die cast, molding dies. Class 3 steels are used to make TEDs that act upon the material being worked over the partially, wholly reforming without changing with the actual dimension, include the being dies and forming dies and twisting dies. Class 4 are used to make dies working under heavy pressure to produce the flow of the metal material caressing into the desired form, that include the crimping of the dies, embossing dies, heating dies, extrusion dies, and staking dies. Steels in the steel group have carbon content range of 8,300 to 1.55%. They are rarely welded. Carbon content, they are rarely welded because of the excessive hardening produced with the fusion zone of the base metal. If arc welding is done, either mild steel with the stainless steel electrodes can be used. Uniform high preheating temperature up to 1,000 degrees must be used when welding tool steels, and general precautions should be taken with the requirement of the welding. High carbon steel with the welding flare shall be adjusted to carbonize to prevent burning out of the carbon in the weld metal. The welding should be done as quickly as possible, taking care or not to overheat molten metal after the welding, and the steel should be treated with the restore of the original properties. Drill rods can be used as filler rods because of the high carbon content compares closely with the tool steel. Flexible, suitable weld cast iron should be used in small quantities to protect the puddle of high carbon steel and remove oxides of the welded metal. Your welding technique: when welding tool steels, the following techniques should be kept in mind. If the parts of the weld are small, they should be annealed and softened before welding. The edges should be preheated to 1,000 degrees Fahrenheit. Depending on the carbon contact thickness of the plate, the welding should be done with either a mild steel or high steel strength electrode. Hard carbon electrodes shall not be used with the welding tool steel. Carbon picked up with the base metal, the filler metal will cover the weld to become the glass hard, and whether it is mild steel with the weld, the metal can absorb additional carbon without becoming excessive hard with the weld metal. Also then can be heat treated with the restore of the original properties. When welding, stainless steel electrodes, the edge of the plate shall be preheated to prevent the formation of hard zones of the base metal. The weld metal must be deposited in small stringer beads to keep the heat input in a minimum. Of the general application procedure for the same as required for the medium and high carbon steels. There are 4 types of dies steel. The repairable, they are water hardening dies, oil hardening dies, air hardening dies, and hot work tools. High speed tools can also be repaired. Alright, your high hardness alloy steels. General, a large number of variety of alloy steels can be developed and obtained with high strength, with a high hardness, corrosion, or resistant other special properties. Most of the steels, depending on special heat treatment, the process in order to develop the desired characteristic of the finished state. With all steels that have great strength, with the durability of the other carbon steels, and their general strength is secured with less material weight. High hardness alloy steels include chromium alloy steels. Chromium is used as the alloying element in carbon steel. It includes hardening ability, corrosion resistant, shock resistant, and given a high strength with little loss in ductility. Chromium, large amounts of the shortness, the spark stream, and 1/2 of the same steel with chromium, but does not affect the spark stream brittleness. Nickel alloy steels. Nickels increase the toughness and strength of the ductility of the steel liners and hardening temperature of the oil quenching rather than a water quench is used. The hardening nickel sparkle that has a short, sharpening, defined dash of brilliant last light just before the work. High chromium nickel alloy steels. High alloy steels covered with wide range of composition, stainless, corrosion, heat resistant properties with the alloy content are due to the formation of very thin oxide film when it forms on the surface of the metal. The sparks are straws colored near the grinding wheel, white near the end of the streak of the medium volume of the streak of the have the moderate number of fork bursts. For magnesium alloy steels, magnesium is used in steel produced with greater toughness, wear resistant. Each of the easier hot rolling forging increase the magnesium content, decrease weldability of the steel. Steels contain magnesium produce smaller in carbon content. Carbon spark matter, increased magnesium, increased volume, spark stream, intensity of the burst of steel containing more than normal amount of magnesium will produce a smaller spark with a high carbon steel with a lower magnesium content. Alright, your molybdenum alloy steels. Molybdenum increased hardenability, which is the depth of the hardening possibility of the heat treatment. The impact of the fatigue of the property of the steel improved up to 0.60%. Molybdenum above 0.60%. The molybdenum impact fatigue proper is impaired. Welding where resistant is improved. Molybdenum content above 0.75%. Molybdenum sometimes can, combined with chromium, tungsten, vanadium, and other desired metal steel containing elements, produce characteristics of spark. There's a detached arrowhead similar to the wrought iron, which can be even with fairly strong carbon bursts. Molybdenum alloy steels can either be nickel or chromium. Or titanium, niobium alloy steels. These elements are additional to the alloy agents, low carbon corrosion resistant steels. They support resistant intergranular corrosion after metal is subject to the high temperature prolonged period of time. Alright, tungsten alloy steels. Tungsten alloying element of the tool steel tends to produce a fine, dense grain when used relatively small quantities. When used in large quantities, from 17 to 20% of the combination of the other alloys, tungsten produces the steel with the retained with the hardness. A high temperature of the element is usually a combination of the chromium or other alloying agents. In a spark test, tungsten will show the dull red color with the spark stream with the near the wheel, but also shortens the spark stream, decreases size, or completely eliminates the carbon burst. The tungsten steel contains about 10% of the tungsten, causes the short, curved orange and spear points at the end of the carrier lines. The still larger tungsten content causes the small white burst to appear at the end of the small spear pivot. Carrier lines may be dull red, orange, depending on the other elements present, providing the tungsten content is not too high. Vanadium alloy steels. Vanadium is used to help control the gold's grain size. It tends to increase the hardenability, cover the marks of secondary hardness, yet resist tempering is added to steel during manufacture to remove oxygen. Alloy steel is containing vanadium, produces sparks detached arrowheads, end of the carrier line, similar to produce the molybdenum steels. Alright, 9. Silicone alloy steel. Silicone is added steel to obtain greater hardenability, corrosion resistant. Often use the magnesium to obtain strong, tough steels. High-speed tool steels. Tool steels are usually special alloy composition designed for cutting tools with a carbon content range of 0.7 to 0.8%. The difficulty to weld with the furnace induction method of the spark test. Few long spark spades are red near the wheel and star colored near the end of the spark stream. Alright, many of these steels can be welded with a heavy electrode with the shield arc type with a composition some of that of the base metal. Low carbon electrodes can also be used with some of the steel. The stainless steel electrodes are effective where preheating is not feasible. The desired heat treated steels should be preheated if possible in order to minimize the formation of hard zones hard zones or layers in the base metal adjacent to the weld. The molten weld should not be overheated with welding. Heat should not be controlled with depositing the metal in the narrow stringer beads. In many cases, the procedure of welding medium carbon steels and high carbon steels can be used in welding alloy steels. Alright, your high yield strength, low alloy structure steels. General high yield strength, low alloy structural steels. Structural alloy steels are special steels tempered to obtain extreme toughness and durability. The special alloys generally make up the steel but require special treatment to obtain satisfactory weldments. For the steel is our special low carbon steel that contains specific small amounts of alloying elements are quenched and tempered to obtain the yield strength of 90,000 to 100,000 psi and tensile strength of 100,000 to 140,000 psi, depending upon the size and shape. Structural members fabricated with the high strength steel have smaller cross-sectional area. For the common structure, steels have equal strength. These steels are more corrosion and abrasion resistant than other steels. In the spark test, these alloys produce a spark very similar to low carbon steels. Welding technique reliable for the high yield strength, low alloy structural steels can be formed by using the following guidelines. It would caution to prevent underbeat cracking or only low hydrogen electrodes should be used when using high yielded strength low alloy electrodes, low alloy structural steel. Correct electrode. Hydrogen is the number one enemy to sound welds on alloy steel. Therefore, one low hydrogen electrode is to prevent underbeating, cracking. Underbeating is caused by the hydrogen picked up in electrode coating, released in the arc of the bulbs in the molten metal. Moisture control electrode. If the electrode are airtight with the container with the place them immediately open the container with the ventilator with the holding oven set at 200 to 300 degrees Fahrenheit. In the event of the electrodes are not in the airtight container, then ventilated baking oven, bake for more than 1.25 hours at 800 degrees Fahrenheit. Bake electrodes will be placed holding oven until used. Electrodes shall be kept dry and eliminate absorption of the hydrogen. Testing the moisture shown in accordance with the military E22200. Alright, low hydrogen electrode selection. Electrodes identified with the classification number to always marked with an electrode contained with a low hydrogen contained with the last two numbered classification 15, 16, or 18 electrodes 5/32 to 1/8 of an inch in diameter are most commonly used since they are more adaptable. All type of the welds of the type of the steel of the table 714 lists the electrode with the yielded tensile strength low alloy structural steel. Table 715 lists the electrode currently established in the Army supplement supply system. The E indicates the electrode. The first two or three digits indicate tensile strength. The last two digits indicate covering. The numbers 15 and 16 and 18 all indicate low hydrogen covered and low hydrogen E80, E90 recommended fillets. Since they are more ductile, high strength electrodes are desired for the butt weld. Alright, selecting a wire flux and wire gas combination. Wire electrode with a submerged gas arc, gas shield arc welding are not classified according with the strength of the wire flux combinations used in the seals will be relieved. This should contain no more than 0.05 of the percent recent vanadium. When metal can more than 0.05% vanadium may be brittle. Stress relieved when using either the submerged arc, gas arc, metal arc welding process to weld. Yielded strength low carbon alloy structural low strength steel with a wire flux wire gas combination should be same recommended strong strength steels. Alright, high yield strength low alloy structural steel. Preheating welding plates up to 1 inch of thickness. Preheating above 50 degrees Fahrenheit is not required to remove the surface of the moisture over the base of the metal. Table 716 contains the preheating temperatures. Alright, by F, welding heat. General. It is important to excessive weld heat with the concentration in order to allow the welded area to cool quickly. Either the heat input with the nanograph or the heat input calculator can be used to determine the heat input of the weld. Heat input nanograph. To use the heat input nanograph and find with the volts over the common one with the draw line with the amps value of the column 3 and frame the point of the line of the intersects column 2. Draw another line with the inches minute value of the column 5 with the read the heats on units and point for the second line of the intersect column 4. Heat units represent thousands of joules per inch. For example, the 20 volts of 30 amps of the line intersecting column 2 with the value 6 at 12 inches a minute. The heat input is determined to be 330 heat units or 30,000 joules an inch. Or your heat input calculator can be made by copying a paper pattern printed with the inside of the back of the covered manual out of this plastic, light cardboard, other suitable material with the cutting of the pieces. If no suitable material is available, the calculator may be assembled the cutting of the pattern out of the back of the cover. 2 pieces of the cutout with the hole punched in the center of each of them assembled the use of the paper fastener. Some of the similar device which will allow the piece of the rotate to determine welding heat input using the calculator. Rotate the value of the volts of the scalar in a line directly with the opposite value of the speed of the inches minute scale. Value of the amps will be then aligned directly opposite of the calculated value for the heat units as with the nanograph heats of the represent the 1,000 joules per inch. For your maximum heat input, check for the heat input with the obtained with the nanograph of the calculator again with the suggested maximum table 17 and 717, 718 with the calculated values too high with adjust for the amperage travel speed, preheat temperature for the calculated heat is within the proper range for the temperature with the until calculated heat with the proper range. The tables are applicable to single arc and shield metal and submerged arc and gas tungsten arc, flux core arc. And gas metal arc process, but they're not practical. They are not applicable to multiple arc, electroslag welding, other heating input vertical welding processes, such as welding made with these. If the T1 seals shall be reheated, treated with the quenching or tempering welding conditions exceeding the range of the nanograph of the calculator. Heat input can be calculated with the following formula, which was heat input 1,000 joules per inch or equals to amps times volts times 60 over the speed of the inch per minute. Or welding process. Reliable weld with a high yielded strength with an alloy structure can be performed by choosing an electrode with low carbon, low hydrogen contact, selecting the proper wire flux and wire gas combination when using submerged arc gas metal arc processes. Using a straight stringer bead with whenever possible to avoid using weaving pattern. However, the need to be the restrictive partial weave pattern. The best results are obtained with a slightly circular motion with electrical load with the weave are never exceeding with the 2 electrode diameters. Never use a full weave pattern. The partial weave pattern should not exceed twice the diameter of the electrode. Skip weld is practical peening of the weld sometimes recommended, but to relieve the stress of the cooling large pieces fillet shall be made smooth, correctly contoured. Avoid toy cracks. Undercutting electrodes used for fillet welds should be low strength, though they can be used with the butt welds Air hammer preheating fillet welds can help to prevent cracking, especially with the welds to be stress relief. Soft steel with the pedals can help also absorb the shrinkage forces, but welding in the two area with the before actual fitting and fillet welding strings are due crack and the baby start with a bead as laid in the toe area with the ground off the prior to actual fillet welding. The butt weld bead must be located so that the toe of the fillet weld drains directly actually during actual fillet welding. Because of the additional material involved with the fillet weld, the cooling rate is increased. The heat boost may not exceed above 25%. Or cast iron. General cast iron is an alloy of iron, carbon, silicone, in which the amount of the carbon is usually 1.7% or less than 4.5%. The most widely used type of cast iron is known as gray iron. Gray iron has a variety of composition, but is usually such as primary perlite with maybe graphite flakes deposited throughout. There are always alloy cast irons which contain small amounts of chromium, nickel, molybdenum, copper, and other elements to provide specific properties. Another alloy iron is a synthetic cast iron when modified with additional nickel, other elements reduced in transformation temperature so that the structure of synthetic room at normal temperature. Synthetic cast irons have a high degree of corrosion resistance. In white cast iron, almost all of the carbons are combined and formed to provide the cast iron with a high strength. High hardness with abrasion resistant. Malleable cast irons are made with the white cast iron special annealing heat treatment changed with the structure of the carbon of the iron. The structure is changed perlic and ferritic, which increases the ductility. Your non-dollar iron and ductile cast irons are made with additional magnesium alloy or aluminum, which will either tie with the carbon confined state, will give the free carbon with a special nodular shape rather than normal flake-like shape, and the gray cast iron structure provide with a great degree of ductile malleability of the casting. Cast irons are widely used as agricultural equipment on machine tools as bases and brackets and covered with pipe fitting for the cast iron pipe with the automobile engine blocks, heads, and manifolds and water preps. Cast irons are rarely used in structural work except for the compression members, widely used for the construction of machinery counterweights and for the other applications for which weight is required. Great cast irons are low ductile, therefore will not expand and stretch with any considerable extent before breaking or cracking because of the characteristics of the preheating necessary with the cast iron welded with the oxyacetylate welding process. It can be, however, welded with the metal arc process without preheating with the welding heat carefully controlled that can be accomplished by the welding. Only short length of the joint of the time, allowing the section to cool by the procedure heating of the weld with confined in small area of the danger of the cracking of the casting eliminated. Large casting complicated sections for the motor blocks as well with the dismantling and preheating special electrodes designed for the purpose usually desired with a ductile cast iron such as malleable iron, ductile iron, nodular iron can be successfully welded for the best result. The type of the cast iron should be welded in annealed condition. Welding is used to solve the new iron cast iron repair castings to have the failed to serve the joint of the casting in either and other steel parts of the manufacturer of the operation. 5 Table 719 show the welding process that can be used with welding casting malleable nodular irons. Selection of the welding process of the welding filler metal depends on the type of the welding properties desired for the surface life that is expected. For example, when using shield metal arc welding process, a different type of the filler metal can be used. The filler metal will have an effect with the color match of the weld compared to the base metal with the color match can be determined factor for specifically with the solid or repair casting of the difference color would not be applicable. Alright, no matter which welding process selected, certain preparatory steps should be important to determine the exact type of the cast iron for the be welded with whether it is graphic cast iron, malleable, ductile, and exact information is not known. The best assumed the gray cast iron, little or no ductile in general, is not recommended with welded repaired gray cast iron are subject to the heating and the cooling of the normal surface, especially with the heating and the cooling large vary over ranges exceeding 400 degrees Fahrenheit. Unless cast iron is used with the filler metal with the welded metal with the base metal may have different coefficients. Expansion contraction will contribute to the internal stress which cannot be withstood by gray cast iron repair of the type of the casting can be welded with reliability. Surface life of such repairs can be predicted with accuracy. Alright, preparation for welding. In preparation, cast welding is necessary to remove all of the surface materials will completely clean with the casting for the area of the weld. This means with the removal of the grease, oil, and other foreign materials from the welding zone. It is desired to heat the weld area with a short time to remove the entrapped gas from the welded zone of the base metal of the skin. The high silicone surface should also be removed adjacent with the welded area. Both of the face and the root side of the edges of the joint shall be chipped out or ground to a 60-degree angle or bevel. The grooves are involved with the V groove of the 60 to 90 degree included angles shall be used. A V should extend approximately 1/8 of an inch from the bottom of the crack. A small hole should be drilled at the end of each of the end of the crack to keep it from spreading. A complete penetration should always be used since the crack are detecting not completely removed as may quickly reappear under surface conditions. Preheating is desired for the welding cast iron with any of the welding process with reduce extremely ductile filler metal. Preheating will reduce the thermal gradient between the weld and remainder of the cast iron. The preheating temperature shall be related with the welding process. Filler metal of the type, mass, complexity of the casting. Preheating can be done A with the normal method. Torch heating is normal U with the relatively small castings weighing 30 pounds or less. Large parts more than furnace preheating. In some cases, the temperature furnaces are built around apart rather than taking part of the furnace in a way that can be maintained with a high temperature interpass temperature furnace during welding. Preheating should be general since it helps to improve the ductility of the material, will spread shrinkage stress over the large area, avoid critical stress at any one point. And preheating tends to often soften the area adjacent to the weld. It is also assists in one of the degassing of the casting. This term reduces the possibility of the porosity of the deposit weld metal, increases the weld speed. Our slow cooling post-heating treatment be involved improve the machinable the heat affected zone of the cast iron adjacent to the weld. Post-cooling should also be as slow as possible. This could be done with the cover of the casting and insulation material to keep a breeze from it. We'll read to section 4. Our welding techniques, electrodes. Cast irons can be welded with a coated steel electrode with a method that should be used with the emergency measure only. Using steel electrode with a contraction steel welded metal. The carbon picked up of the cast iron by the welded metal with the hardness of the welded metal with a rapid cooling must be considered. Steel shrinks more than cast iron when seated. Ceased with from molten to a solid state. With steel electrode is usually uneven shrinkage and will cause strains at the joint after welding. Large quantity of filler melter is applied with the filler metal is applied with the steps that are taken to overcome the difficulty to prepare with the should be welded with depositing weld metal short stringer beads at 0.75 to 1 3/4 to 1 inch along with the back step of the skip of the procedure to avoid hard spot with the air should be struck into the V, not a surface of the base metal with each for the length of the welded metal applied with the joint should be lightly peened while hot with a small ball peen hammer allowed to cool for the additional welded metal applied with the peening and the action of the forged metal relieves the cooling strain. The electrode should be used should be 1/8 of an inch in diameter to prevent excessive welding heat. When welding should be done with reverse polarity weaving on the electrode shall be heat held to a minimum. Each weld metal deposit with a thoroughly cleaned before additional metal is added. A cast iron electrode must be used with the subsequent machining of the welded joint with the requirement of the stainless steel electrode are used with the machining of the weld that does not require the procedure of making the welds of the electrode with the same and its outline with the welding of the mild steel electrode. Stainless steel electrode providing is excellent for the fusion between the filler and base metal. Great care must be taken to avoid containing cracking of the weld. Steel expands and contracts approximately 50% more than mild steel with the equally changing for the temperature. Arc welding. The shield metal arc welding process can be utilized with the welding cast iron. 4 types of the filler metals can be used with the cast iron covered electrode with the covered base, copper base, alloy electrodes, copper nickel base, alloy electrodes, mild steel covered alloys. Covered electrode. These reasons using each of the different specific type of electrodes include machinability with the deposit color match, with the deposit strength, with the deposit, with the ductility of the final weld. When arc welding with a cast iron electrode or ECI, preheating between 250 to 800 degrees Fahrenheit, depending on the size of the complexity of the casting needed to machine deposit adjacent area with a high degree of the heating, the easier it will be to machine the weld deposit in general. It is the best use of a small size electrode with a relatively low current side, setting a medium of the flat position prohibit wandering skip welding procedures shall be used with the painting and does not recommend electrodes should provide with the excellent color match can be gray iron and the strength of the welded area will equal the strength of the base of the metal. With the two types of the copper base electrode, the copper tin and copper alloy types, copper zincs cannot be used in the arc welding electrodes because low boiling temperature of the zinc will volatilize the arc and will cause weld porosity. When copper-based electrodes are used with the preheat 250 to 400 degrees Fahrenheit, recommended small electrodes, low carbon content used in the arc shall be directed against the deposited metal and puddle to avoid penetration of the mixing of the base metal with the welded metal. The slow cooling is recommended after the welding of the copper-based electrodes does not provide a good color match. The three types of nickel electrodes used with the welding cast iron electrodes can be used with the preheat. However, the heating of 100 degrees Fahrenheit is recommended. Electrodes can be used in all positions. However, the flat position is recommended. Welding slag can be removed between the passes of the nickel and the nickel iron being deposited extremely ductilely will not become brittle with the carbon pick up the hardness of the heat affected zone can be minimized and by the reducing penetration into the cast iron base metal with the technique mentioned above the playing with the arc on the puddle rather than the base metal with the minimize the dilution with the slow cooling the necessary post heating minimizing improving the machinability of the heat affected zone with the nickel based electrodes do not provide a close color match. Copper nickel type electrodes have two grades. Either of those electrodes can be used in the same manner as a nickel and nickel iron electrode, which are about the same technique, and the result of the deposit of the electrode do not provide a color match. Alright, mild steel electrodes are not recommended with a welding cast iron if the deposit of the machine of the metal deposit will be sufficient in the carbon to make with a high carbon deposit impossible to machine additional with a steel deposit with a reduced level of ductility with the result of the increase of the carbon content. The type of the electrode should be used only with a small repair that should not be used when machining is required. Minimum preheat is possible with small repair jobs. Small electrodes are low current repair with a minimized dilution, avoid with the concentration shrinkage stress. The short weld using in the watering sequence of it should be used with welded should be painted as quickly as possible after welding. Mild steel electrode deposits provide a fair color. Carbon arc welding cast iron. In iron casting welding with the carbon arc casting iron rod and carbon arc iron welding flux. Joining should be preheated with moving the carbon electrode along the surface to prevent the too rapid from cooling after welding. The molten metal with the must be poured to carbon electrode as soon as possible. The slag oxide with the form of the surface of the welds may be with the carbon arc cooled may slope more slowly as are not hard as those made with the metal arc of the cast iron electrode. The welds are machinable. Oxy-fuel gas cutting. Oxy-fuel gas welding. Oxy-fuel gas process is often used in welding cast iron. Most of the fuel gases can be used with the flame as neutral with slightly reducing the flux shall be used. The two types of filler metals available. The cast iron electrode will be as strong as the base metal. The good color match is provided with all of these welding rods. The optimum welding procedure should be used regardless of the joint preparation, preheat, and post-heat. The copper zinc rods produce brazed welds, and the two classification magnesium bronze and low fuming bronze deposited bronze are relatively high ductile boil, not provide color match. Alright, brazing and braze welding. Brazing is used to join cast iron with a cast iron and steel. In these cases, the joint design must be selected with the brazing with a capillary action, causing filler metal to flow between the closing fitting parts. Torch method is not normally used in addition with the carbon arc, the twin carbon arc, of the gas tungsten arc, and the plasma arc can also be used as the source of the heat. The two brazing filler metals always normally used with both copper zinc alloys. Brazing welding can be also used as a joint cast iron brazing welding, and the filler metals is not drawn into the joint with a capillary action, sometimes called the bronze welding. The filler metal having the liquidus above 850 degrees Fahrenheit should be used. Braze welding not provide a color match. Braze welding can also be accomplished with shield metal arc welding, gas metal arc welding process. High temperature preheating will usually required for the brazing welding unless the part is extremely high with the complexity of the geometry. With the braze welding deposit with extremely high ductility will compensate with the lack of the ductility of the cast iron. The heat of the arc is sufficient to bring the surface of the cast iron temperature to that at which the copper-based filler metal alloy will make the bond of the cast iron, since the little or no intermixing materials joining adjacent as the welded base metal. It's not appreciable hardened weld adjacent area is machined after the weld is completed, generally 200 degrees Fahrenheit preheat with the position most applicable with the application tooling rate is not extremely critical with the special relief of heat treatment if it's not usually required. The type of the welding commonly used with the repair welding automotive parts Agricultural implemented parts and even automotive engine blocks and heads can only be used if the absence of the color match is not objectionable. Gas metal arc welding. Gas metal arc welding process can be used for the making of welds, malleable and cast iron, several types of mild steel using 75% argon, 25% carbon dioxide, nickel copper, 100% argon for shielding, silicone bronze, 15% argon, 50% helium. In all cases, small diameter electrodes should be used with low current with mild steel electrode wire or argon CO2. The shield gas mixture is a minimized penetration in the case of the nickel-based filler metal. The copper-based filler metal, deposit filler metal is extremely ductile metal steel which provides a fire color match. A higher temperature usually required with reduced residual stress and cracking techniques. Your flux core arc welding process has been used for the welding cast iron successful application. Had been a nickel-based flux cord wire, electrode wire normally operated with the CO2 shielding gas, but with lower mechanical properties not objectionable, can be operated without external shielding gas. The minimum preheat temperature can be used with the technique, with it should be minimized with the penetration into the cast iron base metal. With the post heating is normally not required, and color match is not obtained. Are studding. Cracks are large castings, sometimes repaired with studding in the process of the fracture, with the removing and grinding of the V groove. The holes are drilled and taped with the angle of each of the side of the groove of the studs are screwed into the hole with a distance equal to the diameter of the studs, with the upper end of the project should approximately a quarter of an inch above the cast iron surface. So the studs shall be sealed and well placed. In 1-2 beads with either studs but tied together. The weld metal beads. Weld metal should be short length at each length of the peen, but it will not prevent high stress from crack. Upon cooling, each bead shall be allowed to cool and thoroughly clean before additional metal with the deposit of the studding and method can be applied. The edges of the joint shall be chipped out with a machine round nose tool forming a U groove in which the weld metal should be deposited. In Figure 710 shows the studding method of the cast iron metal stud, welded bead stud for fracture ground out, and then other welding processes can be used with the cast iron. The thermite welding can be used to repair certain types of cast iron weld machine tool parts. Soldering can be used with the joint cast iron, sometimes used with the repair smalling defects, and small casting flash welding can also be used to welding cast iron. Section 4, General Description Weldability Non-Ferrous Metals. Testing.